Hi, computer enthusiasts. Recently, I have been diving into the topic of GraphDB. Why? Well, I like mind maps. Actually, when I introduce myself, I use this slide, and it does not only tell you that I like locomotives and programming, but also mind maps. Actually, I have spent my whole life searching for the complete mind map. I mean, how great would that be? You have your mind, and you can just transpose it into the open world. Okay, but I never had an idea how to start with this perfect mind map explaining the whole world. So I made some steps towards it. So let's have a look at what I did. I'm a bit into Linux, so I made a mind map about Linux shell programming. So here, for example, you see that Linux shell scripting, one step, so let's say one subtopic about it is external programs. Another topic about it is string operations. However, these two topics are interwoven. For example, there are external programs that do string operations. And what is super important to me is that with these mind maps, you can always zoom into a topic. So you would only see Linux shell scripting and those topics that are directly adjacent with it. So that would reduce complexity. Second, you could zoom out of the topic, but increasing complexity. Third, you could traverse the nodes. For example, you could go from Linux shell scripting, you could go to string operations. And then you could make a YouTube video only on string operations, and that you can use them under Linux is just one of the many aspects. Another aspect could be Windows. For example, Windows PowerShell programming of string operations and so on. So you can traverse from one node to the other, just as if you have a street map on your computer where you can always zoom in, zoom out, move to the next town, and so on and so on. And the same I want to be able to do with my mind, with all the topic, with all the knowledge that I have. Then I click on Linux shell scripting, and I get all the information about Linux shell scripting that I know, get a tutorial by me about Linux shell scripting, cool stuff. And then one topic that is, of course, related to Linux shell scripting is Linux. So then I go to Linux, and then from Linux, I can not only do shell scripting, I can also do installation and so on. So what you see is that this topic becomes incredibly complex. And this is why it is so hard to make a really good mind map. I find this is a really good mind map, but I stopped when complexity was becoming too high. So what I really would like would be an interactive mind map where I could say, okay, Linux shell scripting, zoom out a bit, zoom in a bit, and then I could also put in another node like Linux, and then another node like operating systems, then another node like Windows PowerShell scripting, and so on. And then I would have a complete circle. And that is the next important thing in my perfect mind map, that all these nodes are created equal. And you can have one as the central node, but whenever you decide, you can just traverse to another node, and this node becomes the central node. This is how my mind works. I mean, this is how explaining things works. You come from one topic to the next, to the next, to the next, if you want. So, and this is the kind of mind map I like. And as I have already said, recently something happened. And that was that I became a lecturer, and I have some students, and these students were about to build a partner portal. So you could find your partner, your sexual partner. I mean, you as a man could be searching for women, of course, also for men. However, you're looking for something like, may I say it, Parship, okay? And then you go to and you say, okay, I'm a male living in Berlin, and I'm searching a female, and I have these hobbies and so on. This is where they introduced GraphDBs to me. If you are now thinking that GraphDBs and MindMaps have something to do with each other, you may be right, but hear me out on this. So GraphDBs does not mean that we are talking about graphics. We are talking about mathematical graphs, those things that consist of node, edges, and properties. For example, here we have such a graph. We have Ben, he lives in Hamburg. So Ben is a node, Hamburg is a node, there's an edge between, and the property of this edge is called lives in. By this, you can very well model the relationship between all these things, and that is also the first-class citizen of GraphDBs. Relationships are the first-class citizen of GraphDBs. Relational databases, by the way, they're the first-class citizen as tables. And of course, tables also have relations between each other. So we talk about entity relationship diagrams and relational databases. But the key thing to understand is that GraphDBs care about, let's call it connections or relations. Yeah, and here you see something that you could use later for a partner finder. Maybe Ben and Ada are a good couple, because, but maybe not, because they live far apart and they have no connection to each other because they have different hobbies. And all this you can very easily find out with GraphDBs, and it becomes a bit complicated to find out with relational databases and the so-called structured query language, or SQL. For example, if I were to say, which friends does Ben have, and friends of friends that have the same hobbies like him and do not live further apart than 100 kilometers. This would be very easy to find out with a GraphDB, and it would be hell to find out with a relational database. So this is where GraphDBs excel. It is when relationships or connections are in the center of what you want to know more about. Yeah. And if I were to fill this database with the nodes that we have seen in the last slide, then I would do it about like this. Create person, name Torsten, then the age, and then where they live in. I just put a black square over where I live in, but here you could see create person named Ben, and he lives in a node that is called city, and the name is Hamburg. Then you merge, which means you make edges for the interests, and you make that Ada, for example, likes jazz, and Ada likes to be a foodie, and all that stuff. And this is how you insert your data. So with SQL databases, you would use create table and insert values. And here, this is how you insert nodes and relationships into a GraphDB. Now I also have a query in GraphDB for you. So let's find one partner for me. So let's find a partner. I live in my city. The candidate lives in candidate city, and the candidate cannot be me. And the age of the candidate should be greater than 28 and smaller than 38. And the distance between my city and the connection city should be less than 300 kilometers, and then it should return the candidate name, and this is my future life partner. Okay, it does not really look at the sex or the animal type of my life partner, but okay, it's something that you can do, but you can also get a rank out of partners that could be good for me, and this is where you can easily change it for other use cases. Yeah, for example, the propensity to buy something like that. But here, let's stick with the idea that I'm searching for a partner, and the good thing should be, a good thing is if we have the same interest, and also a good thing is if I know a person who knows the candidate, so we are already friends of friends, and then just return the name of the candidates as a list, and here's the weighting. So if we have shared hobbies, then this is weighted with 0.5. If we have friends of friends in common, then this is weighted with 0.2. And yeah, it makes me 5 proposals. And you see that the syntax is completely different from SQL, and that it is more geared towards finding connections and relationships. And this brings me to the next slide, where I want to explain where do GraphDBs excel. And there I have some examples for you. For example, in social network like Friend Finder, and it is in SQL, it is really hard to formulate a query. Find me the friends of friends within 3 hops who like jazz. That would require a nasty recursive join, and that would be super nasty. In logistics, you can use GraphDBs to find the shortest route between 2 cities. In IT, you can find out what service will be impacted if this specific server fails, or this specific node fails, this specific microservice fails, or this specific network switch. The other good thing that you get with GraphDBs is explainability. Yeah. This is the graph which led to the conclusion why this is the perfect partner for you. Much better than you have it, for example, with embeddings. And of course, in fraud detection, if several people, for example, use the same mobile phone for different accounts, then you can think that something fishy is going on here. Okay, in short, GraphDBs excel where it is more important how things are connected than what they are. Yeah? Because with as GraphDBs do not replace relational databases, but they make them better. Thank you for your attention, and I'm looking forward to your comments. See you there.